Friends, welcome to s.mathguru classes. So our main discussion is variation of parameters of differential equation. So we solved some problems. Now we consider the remaining problem. So solve by the method of variation of parameters d square y dx square minus 2 dy dx equal to e to the power x sin x. This is our problem. Now we want to solve this problem by using variation of parameter. So here given d square y dx square minus 2 dy dx equal to e to the power x sin x, and this can be written as capital D minus capital D square minus 2d into y, and on right hand side e to the power x sin x. So auxiliary equation m square minus twice m equal to 0, m common, m minus 2 equal to 0, m equal to 0, m equal to 2. We get two distinct roots 0 and 2. Therefore complementary function equal to c1 e to the power 0x, c2 e to the power twice x, or we can write cf equal to, this is c1 plus c2 e to the power twice x. We get this. So here y1 equal to 1 and y2 equal to e to the power twice x. This c1 into 1 and c2 into this, one is considered y1, another is y2. Now y1 y2 dash minus y1 dash y2, y1 is 1, y2 dash, this is, if we differentiate this we get 2 e to the power twice x, y1 dash 0 e to the power twice x, this is 2 e to the power twice x. We get this value. Now particular integral equal to u y1 v y2. This is our particular integral in case of variation of parameter. Now u equal to integration minus y2x by y1 y2 dash minus y1 dash y2 dx. This value is 2 e to the power twice x, and this is y2. y2 means e to the power twice x, and x means this right hand side, e to the power x sin x dx, and these two will be cancelled. We get minus 1 by 2 e to the power x sin x dx. This is our u. Now we using the formula, we know this formula, integration e to the power ax sin bx dx, this equal to e to the power ax by a square plus b square into a sin bx minus b cos bx. This is our formula. If we write directly, we get this result, e to the power ax by a square plus b square a sin bx minus b cos bx. We get this. Now here if we comparing with this, a means 1 and b means 1. Using this formula we can write directly minus 1 by 2, this equal to e to the power ax. Ax means only e to the power x. 1 square plus 1 square. A sin, a means 1, sin bx, bx means x, minus 1 cos bx, bx means x. So we get minus e to the power x 112, this is 4 sin x minus cos x. This is our u equal to minus e to the power x by 4 sin x minus cos x. This next we consider v equal to y1 x by y1 y2 dash minus y1 dash y2 dx. This is y1 means 1 into x, x means e to the power x sin x, and this value we know 2 e to the power twice x, and these 2 taking outside e to the power twice x, this one x minus x sin x dx, we get this. So here a means minus 1, b means 1. Using the same formula, we get 1 by 2, 1 by 2 into 1 by, not 1 by e to the power minus x by minus 1 square plus 1 square, and this is a sin x, a means minus 1, sin bx means x, minus b means 1, and cos bx means x. So ultimately we get 1 square is 1, this is 2 e to the power minus x by 4 minus sin x minus cos x. We get this is our v. Now pi equal to particular integral equal to uy1 plus vy2. U means this is our u minus e to the power x by 4 sin x minus cos x, this, and this one e to the power x by 4 minus sin x minus cos x, we get this, and e to the power x by 4 is common, here we get minus sin x plus cos x minus sin x minus cos x. Cos cancel, e to the power x by 4, this one, one thing is mistake, u means this and y1 means 1, y1 means 1, y2 means e to the power twice x. Now I rewriting this, this is u into y1 is 1, v means this one, into y2, this, and minus e to the power x by 4 sin x minus cos x, and if we multiplying with this, then 2x minus x e to the power x by 4 minus sin x minus cos x. Now e to the power x by 4 common, this is minus sin x plus cos x minus sin x minus cos x, and cos cancel, we get e to the power x by 4 minus 2 sin x, 2 cancel, minus 1 by 2 e to the power x sin x. This is our particular integral. Particular integral we get minus 1 by 2 e to the power x sin x. Therefore, general solution is y equal to CF plus PI. Y equal to CF means C1 plus C2 e to the power twice x, and Pi means 1 by 2 e to the power x sin x, and this is our final answer. So answer is c1 plus c2 e to the power twice x minus 1 by 2 e to the power x sin x. This is the final answer. Very easy solution. Here another problem solved by the method of variation parameters d square y dx square 3 dy dx 2y sin e to the power x. Now we want to solve this. Now solution, so this can be written as capital D 3d plus 2 into y sin e to the power x. Now auxiliary equation, this is m square plus thrice m plus 2 equal to 0. This implies m square plus twice m plus 2 equal to 0. If we factorize this m common, m plus 2, 1 common, m plus 2 equal to 0. Then m plus 2 is common, m plus 1 we get, and this will be m equal to minus 2, m equal to minus 1. We get this. Therefore, complementary function, CF equal to C1 e to the power minus x, C2 e to the power minus twice x. This is our complementary function. Here y1 equal to e to the power minus x and y2 equal to e to the power minus twice x. Now y1 y2 dash minus y1 dash y2, this equal to y1 means this e to the power minus x, y2 dash, if we differentiate directly we get minus 2 e to the power minus twice x, y1 dash, if we differentiate this we get minus e to the power minus x, and y2 is minus twice x. This is minus 2 e to the power minus twice x minus plus e to the power minus twice x, and this will be minus e to the power minus twice x. This our result we get. Now particular integral pi equal to uy1 plus vy2. u equal to we know minus by formula y2x by y1 y2 dash minus y1 dash y2 dx, and this is minus y2 means e to the power minus twice x, and x means sin e to the power x, and this value already we find minus 3 minus e to the power minus twice x. We get this one. Then minus minus cancel. If we taking this one in numerator, this power will be positive, 3x minus 2x, x we get. So we get e to the power x sin e to the power x dx. We get this. Now substitution method, let e to the power x equal to z. If we differentiate, we get e to the power x dx equal to dz. Now we change this sin e to the power x, and this one taking here e to the power x dx, and this is sin z, and this one dz. Integration sin z means minus cos z plus c, and z means e to the power x. We get here, no need to write c, this one we get. This is our u. Now v equal to integration y1 x by y1 y2 dash minus y1 dash y2 dx. This implies this value we know, this value is minus e to the power minus thrice x, and y1 means e to the power x, e to the power minus x, and x means sine e to the power x. This one we get. So we get minus this one and e to the power this minus x and this. Now if we taking this one in numerator, then this minus will be plus 3x minus x, 2x we get. So this is minus e to the power 2x sine e to the power x dx. We get this one. Now we arrange this e to the power x sine e to the power x and e to the power x dx. So we consider this. But already we consider e to the power x means z. If we interchange this is z, this is sine z, and e to the power x dx means dz. So we get this one. So using bypass formula, we know the bypass formula. I rewriting this bypass formula, integration fx gx dx. This is fx integration gx dx minus integration ddx of fx minus integration gx dx into dx. These are bypass formula. So here we get algebraic trigonometry, and we know the rule Eilert. According to Eilert, algebraic is first, trigonometry second. We consider this is fx, this one gx, second function. Now using bypass formula, we get minus z integration sin z dz minus integration d dz fx means z integration sin z dz into dz. We get this. This is minus z integration sin z means minus cos z, and this is 1 dz 1, this is minus cos z dz. We get this. Now this will be this minus will be plus z cos z minus minus plus, again this minus integration cos z dz, this, and this is z cos z, and integration cos z means sin z. So this is our v, and putting the value of z, z means e to the power x, this is e to the power x sin e to the power x. We get this one. Now pi equal to uy1 vy2, uy1 vy2. So u means minus cos e to the power x minus cos e to the power x, and y1 means e to the power minus x plus v e to the power x cos e to the power x minus sin e to the power x into y2. y2 means e to the power minus twice x. This is twice x. Now multiplying this is minus e to the power minus x cos e to the power x, and multiplying with this plus e to the power x minus twice x e to the power minus x cos e to the power x, and this is e to the power minus twice x sin e to the power x. If we multiplying, we get this one. But these two are like terms, this will be cancelled. We get minus e to the power minus twice x sine e to the power x minus e to the power minus twice x sine e to the power x. These are particular integral. Therefore, general solution is y equal to Cf plus Pi. This implies y equal to Cf C1 e to the power minus x C2 e to the power minus twice x minus e to the power minus twice x sine e to the power x. C1 e to the power minus x, C2 e to the power minus twice x minus e to the power minus twice x sine e to the power x, and this is our answer. Very nice solution and very easy also.